Hello everyone, welcome to the mathematical session on foundations of algebraic structures and number theory. In this session we are going to discuss about classical theorems and multiplicative functions. So this presentation explores more on the theorems and functions in number theory. We will cover fundamental concepts like Wilson's theorem, Fermat's little theorem and Euler's theorem. These theorems are essential in cryptography and prime number theory and modular arithmetic. So if I want to talk more on this, you can say like these Wilson's theorem, Fermat's little theorem or Euler's theorem. So they play a fundamental role in the concept of congruence. So working with prime numbers and working with prime numbers in congruence. So suppose if we want to understand the remainder of a big term with power of something, for example 24 power 2020 or 2021 or 3000, like, and if it is divided by some number, some prime number. So each and every researcher, maybe a Wilson or a Fermat, they have worked and they have produced their own ideas. From that kind of ideas we can easily find the remainder of very huge values by using the relations given by them. So these theorems plays a wonderful role in cryptography, because in cryptography we work more with number theory and especially on prime numbers. So in order to talk about Wilson's theorem is very important and it plays a very important role when we work with congruence and prime number system. So already you know, number theory studies the properties of integers and their relationships and the types of patterns they occur. And if you talk about classical theorems, Wilson's theorem and Fermat's little and Euler provide fundamental concepts, because they talk about the fundamental concept of congruence and prime number ideas. So how the prime number concepts can be connected with congruence ideas. So these things are wonderfully explained. And next one is the modular arithmetic. So Wilson's theorem is central in understanding the modular arithmetic, which involves remainders and other divisions. So modulo division, such kind. So we can work more on prime numbers if you come across the kind of if you can master these kind of theorems, you can easily work with more ideas on the concept of congruence, where you can easily stimulate, equally understand, equally practice and equally bring out the solutions of huge complex terms. So in Wilson's theorem, the format, the concept what we use is, for any prime number p, we can write p minus 1 factorial is congruent to 1 mod p. So this is the concept given by Wilson in his theorem while discussing about congruent structure in prime number system. So in that, what he says is, if there is a prime number and if you want to find the congruence working into that with a relatively prime structure, relatively prime concept involved into this, then you can work with this idea, that is p minus 1 factorial is congruent to minus 1 mod p, minus 1 mod p. So Wilson's theorem provides a criterion for understanding prime numbers. So that is what I have explained with a simple example. When p equal to 5, so you can write 5 minus 1 factorial, which is 4 factorial. 4 factorial is equal to 24. So the congruency concept into this, that is when 5 is the prime number, you can write 24 congruent minus 1 mod 5. Okay, this is how we can work with Wilson's idea, which is of more importance when it comes into the concept of cryptography, where we work more with the number theory. In particular, we work with prime numbers and positive integers. So thank you for listening to this session, and we will see in the next coming videos.